In reading this linear programming problem, we have several constraints. First, we know that the Heath Bar Crunch ice cream will make between 0 and 50 cones. We'll use x for its variable. The frozen yogurt will make between 0 and 80 cones, and we'll use y for its variable. The total will be at most 100 cones. Therefore, x plus y is less than or equal to 100. To graph, we must separate the two compound inequalities into their separate simple inequalities. X is greater than or equal to 0, x is less than or equal to 50, y is greater than or equal to 0, and y is less than or equal to 80. Finally, we must solve this inequality for y, which gives us y is less than or equal to 100 minus x. After graphing and using the shades functionality, we get this feasible region. The vertices are 50, 0, 50, 50, and 0, 80. Since we're selling all 100 cones, the only vertex that makes sense is 50, 50. The optimization function is 2x plus y. So therefore, the money they make will be 2 times 50 plus 50, or $150. In this linear programming problem, as with any, our first two constraints are that there will be at least 0 bridesmaid dresses and bridal gowns produced. Using x for dresses and y for gowns, this means that x will be greater than or equal to 0, and y will be greater than or equal to 0. The other two constraints are that each dress takes 2 weeks and each gown takes 5 weeks to make. So 2x plus 5y must be less than or equal to 22 weeks, which is our target. Finally, she typically takes at least 3 times as many dress orders as gown orders. Therefore, x must be at least 3 times y. The inequality is x is greater than or equal to 3y. Solving for y gives us y is less than or equal to x over 3. Graphing on the calculator gives us this feasible region. Using the optimization function of 200x plus 650y, producing 11 bridesmaid dresses and no gowns, would give her a total of $2,200, while producing 6 bridesmaid dresses and 2 gowns would give her $1,200 plus $1,300, or a total of $2,500. Therefore, she should make 6 bridesmaid dresses and 2 bridal gowns. Even though you can't make the points up, here's the solution to the bonus problem. Using matrix equations, we set up the system like this. Then we need to find the inverse of this matrix so that we can multiply it by the 2 by 1 on the other side. This is where we will get the answer for x. First, we find the determinant by multiplying a by e and subtracting b times d. Then we switch a and e, change the sign of b and d, and multiply everything by 1 over the determinant. Then do the matrix multiplication. The result for x is e times c plus negative b times f, or minus bf, all over ae minus bd.